In this video, we will do the example sums from example 6.35. The question says, determine whether the pair of straight lines given by these two expressions are parallel, then find the shortest distance between them. So what's the methodology that we would follow? So we'll see the methodology and then we will actually solve the problem. So the methodology is we will rewrite this equation as R is equal to A vector plus T B vector, and the second line as R vector is equal to C vector plus S D vector. Now we know that if B and D, which is vector B and D, are parallel to line 1 and line 2 respectively. So if B and D are parallel, then the two lines are parallel. Okay, so what is our B here? Our B is this. And what's our D? Our D is given by this. So if you compare B and D, we have to see that B must be a multiple of vector D for B to be parallel to vector D. So can you see whether they are, is it a multiple? Now we have a 2 here and we have a 1 here. So let's say 1 times 2. So if we multiply this vector D by 2, so 1 times 2 will be 2. Then 2 times 2 should be 4, but here we have 3. Therefore, these two are not parallel. And then further, to find the shortest distance between them, we will use the formula, which is delta is equal to C minus A dot product with vector B cross product with vector D divided by vector B cross product with vector D. So once we substitute the values of C, A, B and D in this equation, then we will find the shortest distance between them. So now let's proceed to do the problem. So let's compare the two equations to be, should be a T here, R vector is equal to A vector into TB vector, which is our first equation, and R vector is equal to C vector plus SD equation, which is our second equation. So we can define our A as this vector, B as this vector, C as this vector, and D as this vector. Now clearly vector B is not a scalar multiple of D. So the two vectors are not parallel and hence the two lines are not parallel. Okay, so now let's proceed to find the shortest distance between the two lines, and it's given by the formula delta is equal to this. So let's take, first we need to find our B cross product with D. So this is our B and that's our D. Cross product is nothing but the determinant expression where you have I cap, J cap, K cap as your first row, then the coefficients of I cap, J cap, K cap, which is 2, 3 and 4 as the second row, and the coefficients of I cap, J cap and K cap of vector D, which is 1, 2 and 3 as the third row. So solving this determinant, you will get the value as I cap minus 2 J cap plus K cap. If you do not know how to solve a determinant, you can always check my video on determinants. Next, so substituting this value B cross product with D onto the numerator first. So we have vector C minus A vector. So vector C minus the vector A vector. So when we subtract them, you get this dot product with our B cross product with D. So if you actually solve this, it will be minus 2 plus 8 minus 6, which is equal to 0. So our shortest distance delta will be equal to 0. Therefore, the distance between the two given straight lines is 0, what does that mean? That means the two given lines intersect each other. Example 6.36. Find the shortest distance between the two given straight lines. So you have the first line and you have the second line. So what's the methodology that we should follow? So the methodology would be, you're already given this first straight line in the form or vector is equal to A plus T B vector. Next, we need to rearrange the second equation into this form, parametric form. So how can we do that? 2 and 2 minus 1 and 2 would be our drs, and our x1, y1 and z1 are minus 3, 0 and 2. So you will rearrange this equation as our vector is equal to minus 3 I cap, y1 is 0, so you leave that, plus 2 k cap plus s times our drs are 2 minus 1 and 2. So it is 2 I cap minus j cap plus 2 k cap. Further, we can say that if vector B, this is a vector B and this is our vector D, we have to check whether these two are parallel or not, because to find the shortest distance, the formula changes for a parallel line and for a non-parallel line, skew line. So we need to know whether it is a parallel lines or skew lines. Okay, so if B vector is a scalar multiple of vector D, then they are parallel. Okay, so let's see if B and D are multiples. So you can see that 2 is a coefficient of I cap and it's minus 2 here. So if you multiply this D with minus 1, 2 will become minus 2, minus 1 will become plus 1, plus 2 will become minus 2. So B is a scalar multiple of D. So they are both parallel, which means the two lines are parallel. So then for parallel lines, we have to apply the formula for the shortest distance. So now let's proceed to solve the problem. First, arranging them in the parametric form. So we have the first equation already given in the parametric form. The second equation, we are rewriting it in the parametric form. This should be an S here. So having written them in the parametric form, now this is our B and this is our D. And we can clearly see that comparing these two equations, which is, we can define A, B, C and D as A, B, C and D. Further, clearly vector B is a scalar multiple of D. Vector B is a scalar multiple of D. Hence the two straight lines are parallel. And we know that the shortest distance for parallel two straight lines is given by the formula D is equal to this. So we need to find CIA vector cross product with vector B divided by magnitude of B. So CIA vector cross product with vector B is equal to, is given by this determinant. So here the determinant is, the first row is I cap, j cap and k cap. Then the second row would be the coefficients of I, j, k of C minus A vector. So your C vector is this and your A vector is this. So C minus A would be 3 minus 2, which is 1, and 0 minus 3 will be minus 3, minus 2, minus 4 is minus 6. Similarly, the coefficients of I, j, k of vector B. Solving this further, we get this as our, equal to this cross product. Further, Further substituting this value onto the numerator here, we get, well, d is equal to the magnitude of this vector here divided by the magnitude of vector b. For the solving these two, we get the answer as square root of 365 divided by 3. Example 6.37. Find the coordinates of the foot of a perpendicular drawn from the point -1, 2, 3 to the straight line given by this expression. Also find the shortest distance from the given point to the straight line. Okay, so let's sketch this. So here now we're given the point D as -1, 2 and 3, and this is our straight line which is given by this expression here, and we have drawn the perpendicular to the straight line from D. So F is the foot of the perpendicular from D to the straight line. Okay, now we can define the point on the straight line, which is x1, y1 and z1 as a point on the straight line. So let's define that as A. So A is 1, -4 and 3, which is from here. So this A is a point on the straight line. So F, we need to find what is the point of F. Now our straight line is in such an expression that every point on the straight line, if you take the coefficients of I cap, it would be 1 plus 2t. If you take the coefficient of j cap, it will be -4 plus 3t, and the coefficient of k cap will be 3 plus t. So let's write that down. 1 plus 2t, comma, -4 plus 3t, comma, 3 plus t. So this is our points, let's say x naught, just for defining z naught. These are points on the straight line. So our f can also be defined as this. So if f is this, so our f is now defined as 1 plus 2t -4 plus 3t, comma, t plus 3. Okay, so our f is this point here, okay, which is given by this. So our vector df can be defined as vector of minus vector od, and our vector of is nothing but 1 plus 2t I cap plus -4 plus 3t j cap plus t plus 3 k cap, right? So we have defined the vector df. Now we know that df is perpendicular to the line. Therefore, our df has to be perpendicular with the vector b. So we have df. So our dot product of df with vector b has to be equal to 0. So substituting the values here, we can say that 1 plus 2t times, for vector b it is 2 times 2 plus -4 plus 3t times 3 plus t plus 3 times 1 is equal to 0. So if we simplify this, we can find that our t is equal to 1. So once we get the value of t, then substitute in f, and we will get our f is given by this expression here. Okay, so substituting this, you will get our f as 3, minus 1 and 4, right? So this is our f. So we have our point f, we have our point t. So we were asked to find this point, so we already found the point. Now to find the shortest distance between D to the straight line, it's obviously the magnitude of this vector df. Because it's a perpendicular line, this will be the shortest distance. So if you find df magnitude, that would be the shortest distance. Okay, so this is just for an overview for you to understand this problem. Now let's actually solve this problem. So solving the problem, we can now say that comparing the given lines, which is this one, with the expression here, we get a vector as the first expression here and b vector as the second expression here. We denote the given point D, which is minus 1, 2, 3, which is the point here, as D, and the point 1, minus 4, 3, which we already said that that's any point here on the line, because that's the coefficient of I cap, j cap and k cap. So x1, y1 and z1 on the straight line by A. So that is A. So if f is the foot of the perpendicular, so f is the foot of the perpendicular from D to the straight line, then f is of the form which we already, we saw how to get this: 2t plus 1, 3t minus 4, t plus 3, and our df is equal to this expression here. So further solving, we can now say that b vector is perpendicular to df vector. Therefore, we have vector b dot product with df is equal to 0. So t becomes 1. Then therefore, the coordinate of f, substituting the value of t is equal to 1 onto this here, you get f as 3, minus 1 and 4. Now the perpendicular distance from the given point to the straight given line is df, which is df itself, and that would be the shortest distance. So that is equal to, we know what is df vector, which is given here. So substituting the value of t into it, then we get the final result as square root of 26 units.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.